Hello students, today we are going to say about some basic concept from the 11th standard. Already you have studied this concepts and all, but you should have the well knowledge in this topic. Then only it is easy for your 12th. So I am going to take this concepts. So today our topic is filling of orbitals. The filling of orbital based on the three rules. What are they? For principle, Pauli exclusion principle and Hund's rule. So based on these three principles only, you can fill the electrons in orbit. So first we are going to see about the Orff principle. What does the Orff principle mean? Here I am not going to give the book explanation and all. For your easy understanding, I will write some simple hints. As per that, according to Orff principle, you should fill the electron in the orbital from lower energy orbital to higher energy orbital. So for this I have shown one diagram here. This diagram not presented in your book. For my convenience I have written. This is for you easy. See, if you are seeing that, I have written the S shell and all first, then P shell, then D shell and F shell. So here I have shown this orbitals by the arrow marker. See, first the lowest energy orbital first S, then I have shown the 2s. Likewise, I have arranged the orbitals here. So in this orbital, which one having the very lowest energy? 1s, then 2s. After that 2p, then 3s, then 3p. You can ask, ma'am, if you are seeing that third shell, 3s, 3p, 3d having. But here I didn't write the 3d first. I have written the 4s first. Then only I have written the 3d. What is the reason means? The 4s having the lower energy than 3d. That's why I have written. This on one more thing, this you can explain by the basic of the n plus L rule, that we will see later. First just you see the arrangement of the orbital. So this is the Orff principle. Then we are going to see about the Pauli exclusion principle. The Pauli exclusion principle is nothing one. Your book they have given. If you are taking that 2 electron, you can arrange the 2 electrons, the maximum capacity of the each orbital, you can arrange only the 2 electrons. The 2 electrons not having the unique 4 quantum numbers, at least the last one, that means the spin quantum number will vary. Even the first 3 numbers having the unique value, but the fourth one will be changed. That is the Pauli exclusion principle. If simply want to explain means the 2 electrons in same orbital possess a opposite spin. See, I have written I have arranged the electrons in 3 categories. The first one only the correct, because I have arranged the electrons in opposite spin. If you are seeing the next, see the 2 electrons I have arranged in the first one the same position. The third one also same position. This is the wrong method. So I repeat again, 2 electrons in same orbital possess a opposite spin. This is the Pauli exclusion principle. Okay. Next we are going to see about the Hund's rule. Hund's rule is nothing one, the pairing of electron in each orbital. That means that already just now I told you, the orbital have you can fill the each orbital by 2 electrons, maximum capacity of orbital. But the pairing of electron in orbital after filling the each orbital by the single electron. That is the Hund's rule. For your understanding, I am going to write the electronic configuration for the 2 atoms. Based on this configuration, you can understand the Hund's rule. I am going to write the electronic configuration for the oxygen and iron. So you should know the atomic number of the oxygen. The atomic number of the oxygen is 8 and the atomic number of the iron is 26. So now first I am going to write the electronic configuration of oxygen. First you want to write that this is the lowest energy shell. So I am going to write that 1s, 2s, 2p. Enough. Now 1s maximum capacity 2. So 1s 2. Then 2s also that s orbital is, so the maximum capacity 2. Then 2p you can fill the maximum electron 6. But already we have arranged 4 electrons, remaining 4 only. I have written. This is I am going to explain by the orbital diagram. So this is the S shell, only one orbital. Here also this is the first S. and next to the second s orbital, and 2p. You have known already, you have known this. 2p having that means p shell having the 3 orbitals, 2px, 2py and 2pz. Generally I have indicated the 2p. So arrange the electrons. First 1s2 electron I have arranged. Here we have included the Pauli exclusion principle also. Then 2s2 opposite spin I have arranged. Then now here only we are going to apply the Hund's rule. How many electrons are there? 2p4. So the 4 electron, how you want to arrange means, first for each orbital you should give the single electron, 1, 2, 3. Then only you can pair the electron. This is the Hund's rule. For then we are going to say this is the p shell I have given. Likewise I am going to give that ion. The ion you can see the d shell. Atomic number of ion 26. So I am going to write 1s, 2s, 2p, then 3s, 3p, 4s, 3d. Enough. So maximum electrons in the S shell, 1s2, 2s2, 2p6, 3s2, 3p6. Now you count once again. 2 to 4, 4 plus 6, 10, 10 plus 2, 12, 18 electrons only we have arranged. Remaining we are having 8 electrons. So that you want to fill. So 18 electrons we have arranged, then remaining 4s2. 20 you have arranged. Remaining electrons 6 electrons. 6 electrons you can fill in the d shell, because the d electron maximum capacity 10 electrons. So you can fill until fill. Now I am going to explain the orbital diagram. No need to write from the 1s beginning itself. You can just write the 4s and 3d, that enough. So this is the 4s shell and 3d. The d shell having the 5 orbitals, so that you have to draw 1, 2, 3, 4, 5. Okay. Now fill the electrons. Here we are going to apply the Hund's rule. So that 4s orbital having 2 electrons I have filled. Then d shell, how many electrons are there? 6 electrons. First you should give the single electron in each orbital. Then you have to, so 5 electrons we got paired. Then remaining you want to pair the electron from beginning itself. So this is the Hund's rule. Now based on this 3 rule only you can fill the electrons. And just now I told why we are filling the 4s shell first than the 3d shell. That you can we can explain by the basic of the n plus L, that we are going to see. See, before to say about the n plus L rule, you should know the what is the n and L. The NL is nothing but quantum numbers. The 4 quantum numbers we have studied. What are the 4 quantum numbers? N, L, M, S. N means principal quantum number, and L azimuthal quantum number, and M means magnetic quantum number, and S means spin quantum number. Here we are going to take the N and L only. N is the principal quantum number and azimuthal L is the azimuthal quantum number. You want to add this 2. So now I have written the orbitals here. 1s, 2s, already have no answer and so on going. Okay, how ma'am we can identify the N and L means? This is very easy. The N means nothing but you have indicated a number before the shell, before the SP, that is the N value. So for the 1s N value 1, 2s 2, 2p 2, and 3s 3, 3p also 3, 3d N value 3, and 4s 4, enough. And L value is nothing but the L value you can give from the SPDF. L value start from the 0, 1, 2, 3. If one S orbital having the value, having the L value 0. For the P orbital L value 1, and D orbital L value 2, and F orbital L value 3. So here now you forget, here forget the 1, already we have full. You are seeing the S. S means what is the L value? 0. That you have to fill. And S means L value 0. So the L value for the orbital, S means the L value 0. Here also the S 0. And P orbital, that L value 1. Again S coming. So that L value 0. And P orbital L value 1. D for the D orbital L value 2. on the s orbital L value is 0. Okay. Now we are going to add that n plus here. 1 plus 0, 1, 2 plus 0, 2, 3, 3, 4, 5, 4. So, if you are seeing that the n plus L value have it that for the 3D having the maximum. If you compare the 4 and 5, 5 is the maximum value. That is why after filling the 4s electron 1, we are filling the third shell. See here that 4s having, then only we have written the 3D value. What is the reason? That n plus L value, that 4s having the least value. N plus L for the 4s orbital 4 and 3D having the 5. That's why we arranged like this. Okay students, thank you.